Okay, so we'll continue with the quantitative models for credit risk. So last time we have seen some conceptual basis and also qualitative factors. And uh, again, if we are doing business, this is always the combination between technical analysis and the decision making that we'll finally do, right? So I think the quantitative models will always play an important role as uh, like the foundation of um, our decision, right? Foundation means uh, at least you have like a basis for doing that. Maybe at the end you have like a different decision because of other factors. You see the qualitative factors that we have discussed, right? And there are still other external factors that we have not taken into account. For example, the references and even uh, maybe forces by uh, certain entities, right? That will happen. We never know. If you go to a certain place or certain country and there are a lot of like political uh, connections or something like that, right? That we might have to really take into account in real life. But of course, in academic settings and also in uh, theoretical basis for making a decision, then the quantitative models will be the important foundation for that. And we are going to see a lot of models today. Okay, so let me start. Okay, so the first one is probability model. So the probability model started with a very simple model with the regression. I think you have taken some statistics courses or economics or econometrics or something like that. So the first version of the probability model was using a simple regression. Now, if you do a regression, like what you learn in statistics, you have the dependent variable, right? So the dependent variable y is a function of uh, a factor of independent variables. So we have some independent variables that we hypothesize or we conjecture to affect the dependent variable. And of course, the dependent variable here is the probability of going down or default. Right, so uh, this is like probability. It means that uh, based on the historical data, if a company or if an entity or a company went broke, then we'll give a value of 1. And if it didn't go broke, then we'll give a value of 0. So 1 and 0, right? Probability, right? Yes or no. And based on the dependent variable, we can test a series of independent variables. So there could be many conjectured independent variables, right? A lot of ratios that you could test, maybe the debt ratio, profitability ratio, and all other ratios or variables that you could test. So at the end, we'll have something like this, right? So we'll have alpha, right, plus beta of maybe the first variable, right? And then beta 2 of the second variable, and so on. Okay, so we have, yeah, whatever conjectures or whatever hypothesis you make, a lot of variables could affect the dependent variable. And let's see an example here. So in this example, based on the regression analysis that the researchers have conducted, there are two variables here that significantly affect the dependent variable. And of course, the dependent variable is the probability of default, right? PD here, probability of default. And they examine like two variables, debt to equity ratio and sales to asset ratio. And based on the regression, again, this is not part of our course because it's about statistics and regression, but you could imagine like we have like historical data for company I, right, at time t, right? This is like uh, panel data, so entity of I at time t, then we based on the regression we have uh, the first variable of I, right, at time t. So you do the regression, you'll get the alpha, beta for beta on the first variable, and beta on the second variable, beta on the third variable, and so forth. Right? So this is called a regression uh, analysis. So in this simple example, they only use that two variables here. Again, debt to equity ratio and sales to asset ratio. And this is the coefficient, right? 0.5 and minus 0.0525, right? So again, this equation is derived from the regression uh, analysis, right? The regression analysis that they conducted. So in this example, they got like 0.5 is the coefficient on the debt to equity ratio, and minus 0.05 is the coefficient on the sales to asset ratio. So if we believe in this equation, um, then for example, tomorrow or the next time a potential borrower comes to you uh, and based on your analysis or your check, the debt to equity ratio of the company that comes to you is 0.3 and the sales to asset ratio is 2. So you just plug in uh, the indicators that you could find on the data, right? The potential borrower's data. So you plug the number in, right? 0.5 multiplied by here, 0.3, and then here's 2. So you get 4.5%. This is the probability of default of the potential borrower that comes to you. If the debt to equity ratio is 0.3 and the sales to asset ratio is 2. Right? Any question about this one? Simple regression method. Okay, quite familiar with your statistics course. So uh, this simple regression model unfortunately has a major weakness because you can imagine if this is a simple regression model, it's actually not purported for the probability type of model. That's why this model was then improved by the Logit model. So Logit model is still a regression model, but Logit model is specialized for uh, a binary dependent variable. So let's look at this again. So if we do the simple regression model, uh, actually the dependent variable, uh, or maybe I should rephrase my statement. So if we use the simple regression model, actually this is not purported for this kind of dependent variable, right? 0 and 1, right? 0 and 1. So if it defaulted in the past, we gave a value of 1. If it didn't, then we give a value of 0. So it's not purported for this kind of dependent variable. So what is the consequence? We still can do that, right? And you see our example here, actually we still could force the result using a simple regression analysis, right, or simple regression model. However, there's a possibility or there's a risk that something like this might happen. Uh, so in our example here is quite smooth. The example is quite smooth. When a new company coming with a debt of equity ratio of 30% and sales to asset ratio of 2 times, actually we get the probability of default of 4.5%. So this is uh, quite smooth, right? But there's a possibility that it might not be that smooth because the the accumulation of this might be was that outside the range of 0 and 1. So you can imagine, right? In our example here, this has no problem at all because the probability of default is 4.5. But using the simple regression method, we might get a value of, for example, 1.1. Then this is meaningless, right? Meaningless because how can we uh, conclude something that has a probability of 110%? So it's already more than 100%. So it doesn't carry a meaningful conclusion anymore, right? Or it might be lower than zero, maybe 0 point whatever, 0.2, right? So if the probability is minus 0.2, then it's already below zero, right? So why this could happen is because, again, the simple regression model is not purported for binary dependent variable regression. Right? So to fix or to improve this model, then we move to a more appropriate model. We call it Logit. Logit means logistic regression, right? Logistic regression. So it's actually quite similar. If you put into software, uh, it would be using similar procedure. But now with the Logit model, we make sure that all this accumulation here, all this summation here will have the range of 0 to 1. Okay, so this is the improvement on the regression method. So we make sure that the range of the summation, right, alpha plus beta 1 times the independent variable 1 plus beta 2 plus independent multiplied by independent variable 2 plus beta 3 multiplied by independent variable 3 and so on, right? We make sure that the summation uh, will range between 0 and 1, right? So it's meaningful, right? The 0 and 1 means the probability of default is between 0 and 100%, something that could not be guaranteed by the simple regression model. Again, because of the uh, yeah, different purposes of each regression. Right? Any question about this one, the Logit model? So same procedure, but we make sure that, again, the summation here will lie or will range between 0 and 1. So it's meaningful, right? But again, the conclusion would be similar. If you put in uh, the regression equation with potential borrowers coming to you, having the data on the variables of interest, right, the variables that you conjecture will affect the probability of default, then you can find uh, certain prediction or certain projection of its probability of default. Any questions so far? Right, quite clear. So we'll continue the story. Logit model is definitely more proper than the simple regression model. Again, the procedures and uh, conclusion making or decision making are similar. Okay, not exactly the same, but similar procedure, similar conclusion that we could draw from the estimation. Uh, but again, statistics and econometrics are unlimited, right? So maybe someday, if you work in the financial markets, you need more statistics and econometrics and multivariate statistics and something like that, right? So, uh, so this is just an introduction to you, okay? This is again out of the scope of our course. But in statistics, we have, for example, the univariate. So univariate statistics. So this is like we have a series of data and we try to examine whether the data are significantly different from zero or significantly different from one or any other number that we want to test. So you could imagine, right? So one, uh, you can say like one independent variable and one dependent variable. So you could, for example, examine the difference between two variables. You heard of this before, right? The t-statistics, right? T-test, independent sample t-test uh, or pair t-test, right? So univariate. So we have only one independent variable and one dependent variable. But we have multivariate, right? Multivariate. So definitely this has more than one independent variables. Right? So I know this is like simplification of my story, but uh, this is just like the what's that? Yeah, the summary of the big picture of the multivariate statistics. So if we talk about regression, it means that you have one dependent. You saw our example before, one dependent variable, one y variable, and many independent variables. Right? So one dependent variable or one y variable and many x's, right? Many x variables. But there are many other statistical tests or techniques, right? That that allows you to test more than one dependent variable. So uh, maybe someday you'll see some equation. For example, this is like x1, right? X1 is affecting, for example, x2, right? Uh, so x2 is affecting x3, right? But we also suspect that x1 also affects x3. So you see, we have two dependent variables here, right? This also functions as a dependent variable, and x3 also functions as a dependent variable. So if this is the case, we cannot use the regression technique, cannot use the regression method, but we have to use other multivariate techniques. And one of them we'll see here, we call it discriminant function, the discriminant analysis. So this is a multivariate statistics or multivariate statistical technique, but not purely the simple regression method or OLS method that we just saw. Right. So there was a guy named Altman. So it sounds like German name, right? So Altman, since 1960s, he has conducted research on this, and the score is called Z. So we name it the Altman Z score. Right? So we call it Z score to be this is a simple form, right? Z score. And based on his discriminant analysis, he found that there were at least 5 variables here. You see, working capital to total assets ratio, retained earnings to total assets ratio, and so forth. Right? There are 5 variables here, and I think every decade, Altman and also his successors will reconduct research on this, and the coefficients would change, and even some variables would change. Okay, so again, you don't need to memorize this, of course, right? If you forget, you just check on Google, even the newest or the most updated version of the z-score. Right? The successor of Altman would continue conducting research and finding like new coefficients or even new variables that would affect the z-score. So the same thing here, right? Based on this equation, then if a new or a potential borrower comes to you, you just plug in their numbers, okay? You just check, the potential borrower, what is its working capital to total assets ratio? What is its retained earnings to total assets ratio? What is the company's operating profit, right? EBIT, operating profit to total assets ratio, and so on, right? So it's very quite convenient for us because we already got the coefficients, right, from time to time. And based on the original version, 1.81 is the critical value. So if it's below 1.81, it means that the probability of default is quite high. So we've seen an example here. A company comes to you, right? Potential borrower comes to you, and you check the data and you find out that these are the company's data. So the first ratio here was X1 again, working capital to total assets ratio is 20%. And the second one, the X2 is retained earnings to total assets ratio, right? And so forth, right? So we see you plug the numbers into the equation. Okay? And again, the coefficients here are based on Altman's research, right? Again, almost every decade, Altman and his successors would find that adjusted coefficients, right? They would make adjustments from time to time. Okay, so 164, what do you think here? The critical value of the z-score is 181. So if we find a company having a z-score of 164, what do you think? Safe or not safe?
Not safe because it's below 1.81.
That's right. So it's less than 1.81. We should be quite cautious, right? Quite cautious in lending money to the borrower, right? Or maybe if we decide to lend money to this company or this person, we might want to do the credit rationing, like what we talked about 2 days ago, right? We might not be willing to lend out the whole amount, but maybe we just lend out 75% of what the company requested, right? Or 50% even. Okay, so it's quite easy for us to use because we already got the coefficients and also even the equation, right? And again, it will change from time to time, but yeah, quite convenient for us. So here's the thing, right? This Altman z-score is produced or was produced using the US data, right? Because again, in the United States, so data for research are more available, and the regulations also require companies, financial institutions to submit data, right? So it's by law, right? By regulation, they have to submit a lot of data. So the availability of data is better there. That's why the research could be conducted like in a deeper and also in a more frequent fashion. But suppose someday, we never know, right? If you hold like a top position, maybe in Germany or in European Union or something like that, I think it's very important for a country or a region to have its own research equation, right? Of course, we could be inspired by the Altman Z, right? But remember that it's very hard to imagine that if we just get the Altman Z equation and we apply it to everywhere, I don't think that works, right? That doesn't really work properly, right? You get the equation from the United States and you go to like Africa and you just plug in the numbers or something like that. Maybe the conclusion would be quite biased and misleading. I think that's something that I think other parts of the world have to really make their own model. Again, we could be inspired, right? We could be inspired by the process. We could uh, mimic, right? We could, uh, yeah, again, try to emulate what Altman has done. But this might not work everywhere, right? Using the same equation. That's my point. Any question about the regression and then discriminant analysis?
Yes, I have a
Mm-hmm.
question. What happens when the calculated value is higher than our set? I mean, in the case of Karina, it was lower. That means that the risk is higher. But what is when the value is higher than the 1.81, I think, was it?
Ah, actually, the newer version shows that they have like between 1.8 and 2 point somethings, about 2.5. That's the normal area, or you can call it like gray area. So above zero point 0.5, we could conclude that the company is safe, right? So yeah, so probability of default is quite low if the z-score is about 2.4 or 2.5. I think that's the only thing that we could conclude here. So again, this could inspire everyone in other parts of the world to make this kind of equation, right? But it's yeah quite difficult to just use the equation or the coefficients and adapt it everywhere. Just assume that no, this equation could work everywhere. I think it's misleading, right? So every country has to make its own z-score or something like that. And I'm sure in developed countries, those countries have had their own research and z-score or something like this. So below 1.8 is definitely not good. Right? But between 1.8 to 2.4 or 2.5 is the gray area. You could say that it's like yeah, it's normal or not that bad, but not really good. Right? But it's if it's about 2.4, 2.5, then we could say that it's safer because the probability of default is lower. Any other question before we continue with the next model? So the next model here, we are using the term structure of interest rate. So this is not difficult at all. We just need to take a logic. So let's imagine if you invest in government securities and you get an interest rate of I. And of course, today this is very low, right? When you see the uh, US government securities, I think the current yield is about 0.6, let's say 0.5%, right? Maybe in Europe, even a bit lower, like 0.25 or even close to zero, right? In other parts of the world, riskier places, it might be higher, right? In Africa, in many parts of Asia, because they're riskier, they will give higher, right? Higher interest rate. So just imagine, okay? So if you invest in government securities, you get an I interest rate, maybe 0.5 or 1% or something like that. And imagine that if you invest in um a company's securities, just corporate bond, right? Company's bond or something like that, and we would name it maybe K, okay? K interest rate. So just tell me the logic again. Which one will be higher? Which interest rate will be higher? The government securities or the company or corporate securities?
I think the corporate securities,
Why is that so?
because the companies have a higher risk.
Mhm. Very good one. So this number would be higher, right? The corporate bond or corporate securities will pay more than does the government security, right? But now I want you to imagine that if I invest. right? In the government securities, compared to if I invest in a company securities, the utility should be the same. This is just to continue Alina's answer, right? So the numbers are different, right? Of course, if you invest in a corporate's bond, a corporation's bond, they will pay more than the government securities interest rate, for sure, like what Alina said. But now the utility or the satisfaction should be the same. Why is that so, Karina? What do you think? The satisfaction of investing in government securities and investing in corporate securities should be the same. The satisfaction or the utility should be the same. But of course, the numbers are different, right? The yields or the interest rates are different, but the satisfaction should be the same. Why is that, Karina? Any idea?
No, I have no
Uh,
clue.
uh-huh. Maybe who else here? Clara? Any idea? Why the utility should be the same between the two investments?
Maybe because there's no risk of not getting your money back. So with government bonds, you might be more satisfied because you're safer to keep your money than with investing in companies.
Yeah, I understand what you are saying. I think you're pretty close to that one. Just imagine again, if we invest in the government securities, we'll get lower interest rate. Agree, right? Lower interest rate, but the risk is lower as well, right? Lower risk, lower interest rate. And on the other hand, if you invest in like a bond of a company, like corporate bond, right, uh, you get more. So you expect to get more because it's riskier. So you see, the numbers are different, but your satisfaction should be quite similar, right? If you invest in government securities, you assume a lower level of risk, but you also expect a lower interest rate, of course, right? And on the other hand, for corporate bond, you expect to get more, but the risk is higher. So the satisfaction is the same, right? Or should be the same. However, here for this one, the government securities, we talked about this in previous sessions. It's very close to risk-free status, right? Again, you could argue that a government could go broke, right? A central bank could go bankrupt as well. But again, they have a lot of ammunitions, right? A lot of methods that they can use if they need quick money, right? If they need a lot of money in a short period of time, they could print more money, sell islands or whatever, right? So this is very close to risk-free reality, risk-free status, right? But this one is not, right? This is corporation securities. So this one has P. P is the probability of repayment. So we could conclude that if we invest in a corporate securities, um, we are not 100% sure that they will fulfill what they promise, right? So there is a probability of repayment, right? We call it P, right? So tell me now, uh, maybe Tim, right, Tim? So if P is probability of repayment, what is one minus P? So P is probability of repayment. Then what is 1 minus
Then
P?
should be the probability of not getting the payment.
That's right. Probability of default, right? Probability of default. Default means you cannot fulfill your promise, right? You cannot repay your debt. Okay, so if I rearrange the equation here, so probability of repayment is a function of 1 plus interest rate on the government securities divided by 1 plus the interest rate on corporate securities, right? See, just rearranging mathematically, right? So we'll adapt, we'll see an example here. So we see there are two types of bonds, right? The first one is treasury strips. This is the government one. The U.S. Treasury is the Ministry of Finance, right? They call it Department of Treasury. In other countries, we might call it like Ministry of Finance. So the T strips, and this is the corporation bond or corporate bonds, like grade B. Grade B is like, yeah, not that bad, but not really good. That's just normal one. And you see here, this is for maturity of 1 year. This is for the maturity of 2 years. So this term structure, we call it term structure, interest rate term structure. So this makes sense, right? You see, for example, for 1 year maturity, if you invest in the treasury strip, you are promised to get 505, whereas if you buy the corporate bond, you expect to get 10.8%. This makes sense, right? Why? The corporate bond is paying higher. Once again, why? Why is the corporate bond paying higher again?
Because there's a higher risk.
Higher risk, yeah, that's right. So for 2 years, you see the same thing, same logic here. If you invest in the treasury or government securities for 2 years, you expect to get 6. But if you buy the corporate bond, a grade B bond, you are projected to get 13%. That makes sense, right? So now if I ask you, what is the probability of repayment for 1 year? Based on the formula we just saw. So what is the I again here? For 1 year, the government securities will pay how much?
2.05%.
No,
13.
for 1 year, this one, is it 505? I mean, if you buy the government securities for 1 year, right? And then what about the corporate counterpart, 10.8?
Okay, we have different numbers in our chapter.
Oh, okay. Yeah. Okay, sorry.
Yeah.
But yeah, maybe we follow this one, okay? But the same principle, of course, yeah. So we got the information here. So if we want to estimate the probability of repayment for 1 year, how is it again? P should equal 1 plus the government securities we see above here, right? Based on the rearrangement of the formula, divided by 1 plus the interest rate on the corporate bond. So 1, where's the I here? 505. 10.8. So let's calculate together. What is it?
$0.948.
Let me check. Yeah, so 94.81%. You got the same thing?
Yes.
So Max, so please tell us now, what is the probability of default?
It would be 1 minus, it would be 5.19%.
Yeah, 5.2%. Yeah. So the probability of default in 1 year for this corporate bond is about 5.2%, right? Okay, very easy. So what about 2 years? Let's check now. What is the probability of default for 2 years? So it's this one, right? The ratio here, 6 and 13. Up here. So see here, if I draw it, So this one is for the government one, 5. And then this is 6. And then for the corporate one, so here 10.8. And then here, what's that again? 13? Okay, so what is the probability of default for 2 years? What is it again? 1 plus the government one first, right? Okay. But now we have to be careful because,
6%.
yeah, but we have
Is
to be
it
careful
6%?
because it's 2 steps, right? 1 and 2.
Then 3%. We have to divide it by.
No, it's 6%, but what I mean is that when we find the present value of it, it's 2 step back. So this should be what? To the power of 2. Right? This from here, see? 1, 2. And the previous one is 1 because we are here, right? Only 1 step back. So I have to be careful with the power of the equation. And similarly here, 1 plus the corporate bond, also 2 steps, right? Because it's like 2-year maturity. So 1 plus, what is it? 6 to the power of 2, 1 plus 13, yeah, to the power of 2. Yeah, let's calculate together. Okay? Has anyone found the solution?
It's 87.99%.
Okay, let's
Or
check. Mhm. Okay, and then here is yeah, you find this? So the probability of repayment for 2 years is 87.99%. Right? So Dina, what is the probability of default for 2 years?
The probability of default would be 12%.
Yeah, 12%. Or yeah, that's right, 12%. Okay, very easy, right? Very easy for this one. Yeah, we find 80, what's that then? 87.99. Okay, so we can do a lot of adjustment here. What if I ask you, what is the probability of repayment for 1 year, but 1 year from now? Okay, so you see, so far we have got the probability of repayment for 1 year and the probability of repayment for 2 years. But based on this information, by using the mathematical techniques, we could also predict the probability of repayment for 1 year, but 1 year from now. So let's see here. We have the right. You see the information here. 1 year interest rate is 5.05. 2-year interest rate is 6%. So we could guess this one. We could make a projection for this one. Do you remember from your maybe high school mathematics, right? Based on the mathematical technique, we could guess that one. How to do that again? So one, mhm. This should equal what? 1 plus 0.5, right, multiplied by 1 plus something, right? So this one. So you can call it whatever. If you follow the text, I think they call it C. Okay. And for this one, what is the logic for this one? 1.13, the 2-year interest rate should be the function of 1 plus 10.8 multiplied by this one, right? So you can call it X or whatever, or if you follow the text, I call it F, right? Okay, so we could rearrange it. 1 plus C is 1.6 to the power of 2, that is 2 years, divided by 1 plus 5.05. So let's find it here. What is it? So this is 505. Okay, so get division. So what is the so we get what, minus anyone got this one? So this is one. Sorry, this should be plus. Yeah. So we get, and then minus 1, right? Right, 6.96. Did you find the same thing? Anyone got the same thing here? 696. So for this one. What about this one? 13 and 10.8. Where? 10.8. This is to the power of 2, right? This is power 1. So we divide it. And then of course we have to minus 1, right? 1 plus something. So 1524. Do you find the same thing? 1 plus f should equal 1 plus 13 to the power of 2 plus 10.8. And then we get the f is, what's that again? 1524. Okay, so now we get, you see, the 1-year interest rate, but 1 year from now. You see, this is 1-year interest rate, right? 1-year interest rate, but 1 year from now. And also for this one, for the corporate bond, 1-year interest rate, 1 year from now. Okay, and then yeah, we could put into the equation again, probability of repayment for 1 year, but 1 year from now is 1 plus, what do we name it again? C, the government one. divided by 1 plus the corporation one, F. So 1 plus 96% divided by 1 plus 1524. What is it now? Yeah, plus this one divided by 92.81. So, here. Alina, tell us again, what is this one?
Is it the default risk?
P is probability of repayment. So probability of repayment.
Maybe that we get the money back.
That's right. But what period is it? What period?
2 years. We calculate with 2 years to the power of 2.
This is 1 year, but 1 year from now. Look again, right? We got the information. If we find the if we estimate the probability of repayment for 1 year, we got, how much was it again for 1 year? Yeah, 94.81. We did it previously, right? So this is the probability of repayment for 1 year. And then the probability of repayment for 2 years is, do you remember how much was it? This for 2 years? I think we erased it. Yeah, some 80 something, 87 or something. Yeah, this one. 87.99. Right. So again, if you want to estimate the probability of repayment for 1 year, this is between, use another color, this one and this one, right? And we get 94.81. If we want to estimate the probability of repayment for 2 years, so the comparison is between this one and this one. And we get, yeah, we got this one, 87 point, yeah, 87.99. And the last one here, right, is the, we try to estimate the probability of repayment for 1 year, but 1 year from now is between this one and this one. And we got 92.81. You see, 3 different things, right? 3 different things. So, Tim, tell me now, what is the probability of default here? This one.
One minus 0.92, so it's 7.19%.
Yeah, and what period is it again? Can you repeat again? What is the period here? Probability of default for what period?
I think this one was for 1 year. Yes.
1 year, but where is it?
From now on.
1
This
year,
one,
but
right?
1 year from now.
Yes, 1 year, but 1 year from now. Yes. I know it could be a bit confusing. So we have 3 things here. See? Probability of repayment for 1 year, right? Probability of repayment for 2 years. And then the third one, like what Patrick said, probability of repayment for 1 year, but 1 year from now. It's just a mathematical, rearrangement, right? Any question about this one? the principle is always the same. 1 plus the government interest rate divided by 1 plus the corporate rate, right? Just be careful with, so you see, if you have like a long-term estimates, for example, you have the data for 3 years, right? So you could estimate the probability of repayment for 3 years. But by knowing the 3 years, you could estimate, for example, the probability of repayment for 1 year, but 2 years from now. You could imagine, right? This is just the compartmentalization of the interest rate. So by knowing the probability of repayment for 3 years, again, you could estimate the probability of repayment for 1 year, but 2 years from now, right? So just again, the separation of the interest rate from one for every year, right? Any question about this one? Right, we call it term structure. This is term structure is, I think, the one of the most widely used method, because we always compare interest rate provided by government securities and interest rate on corporate securities. Corporate securities have a lot of ratings. AAA is the highest rating. Below that we have AA, then AA minus. We have single A. We have triple B, and so on. So we always try to compare, and the difference is always called the risk premium. Right, the premium. Remember when we calculated the return on a loan, we have the basic rate plus the premium. Right. So we always again compare using the term structure, comparing the government interest rate and the corporate rate. So that could be used to predict the probability of repayment or probability of default. Okay, so if you have question, yeah, please, before we continue. So mortality rate models, so this is quite straightforward. So we try, for example, this one, marginal mortality rate for 1 year. For 1 year, right? So the value of, defaulting grade B bond, right, divided by the value of the whole grade B bond. So we want to know the proportion of grade B bond that actually defaults in 1 year, right? And this one is so I think this is quite, I have to be careful in writing this one. So this is actually the marginal mortality rate for 1 year, but 1 year from now. How do we know this? Because this is at year 2, you see? It's not 2 years, but year 2, right? So this is the value of grade B bond that defaults in year 2. In year 2 means it's for 1 year, but 1 year from now, right? Year 2, divided by the value of grade B bond outstanding, right? The whole thing that exists in year 2. So let's see an example here. Yeah, this is quite interesting. You see, if you're a AAA, right, and these are years after issuance. So the end of year 1, you see, 0, right, is quite strong and solid, right? And you see some of them start defaulting only after year 5, and even the percentage is very low. The probability is very low, right? And you see this is AA. Yeah, it starts defaulting in year 3. It's not that high, right? Only 0.22% defaulting 3 years after its issuance. So it's quite safe, right? Very safe. But interestingly, you see this one, triple C. So there are 8.15% of the securities that default or defaulted after 1 year. 8% is quite high, right? Quite dangerous, right? But Let me ask you a simple question, okay? Knowing this fact, maybe Patrick, right? You know the triple A, double A, triple B, and so forth. And you have triple C, the junk bond, right? The junk securities. But why do you still want to invest in junk securities? What's the main reason? Knowing that 8%, about 8%, might default after 1 year of issuance, even. But why do you still want to invest in like junk securities like triple C?
Yeah, because the interest rate is very high, but it's because of that the risk is also high. So it's a little bit of
Yeah, very good answer.
poker. It's a kind
Yeah,
of poker. Gambling.
that's right. Yeah, that's right. So this is the thing, right? If you have a portfolio consisting of all triple A securities, again the return might be too low, not really interesting. Of course, it's very safe, right? It depends on your client. If you promise your client that this is a super safe product, then of course you want to find as many triple A securities as possible. But if you want to that perform a little bit better, you might want to steal something, do the some modification a bit. So maybe you take like 5% or 10% of your investment into this kind of securities, right? Hoping that, 8% of default in 1 year. Hopefully it doesn't happen to you, right? You hope that you quit this kind of securities quite soon after 1 year, maybe hoping that you don't default in 1 year and then you quit immediately. But this is like uh, if you have a portfolio and you want to increase your performance, then this is something that you want to try. It's personal choice, right? Life is a choice. Just like maybe Patrick or Tim or Clara or Alina or all of you here. If you find maybe you try to find a boyfriend and the boyfriend is like 100% good, it might be a bit boring, right? So you might want like 90%, 95% good and 5% a bit wild or something, right? So, but again, the 95% is good, but 5% a bit, some junk, junk behavior for 5%, right? So it would create a bit more, a bit more sensation, maybe a higher return or something like that. You could imagine, right? Same thing here. So if you invest, you put everything in triple A securities, you get very low return, but of course it's very safe. But on the other hand, if you put all your money in junk securities and triple C, then most likely you will be gone, right? Not good, right? This is, of course, not recommended. Putting a lot of money in junk securities. So interesting fact here. So triple C is definitely quite dangerous, and even below triple B is already dangerous, right? The 1% is defaulting here. For B, even almost 3% is defaulting after 1 year. It's quite dangerous already, but still you can make more money from there. Any question about the MMR, marginal mortality rate, marginal mortality rate model? So you could always renew the research, right, from time to time, checking the newest research outputs. So the next one, this is risk-adjusted RA, RAROC, right? Risk-adjusted return on capital. Right, so risk-adjusted return on capital, right? RAROC model, and the numerator here is net income on a loan, right? And the denominator is the risk. Right? This is quite straightforward, and you have seen the model before. We'll use the duration method again. So the denominator here could be estimated using the duration model. All right, let's see an example here. Have an example here. The credit risk of $1 million loan, right? $1 million loan with a duration of 2.7 years. So the duration has been calculated for us. Right? This is the good news. Triple A borrower. So this is a good one. Right? A borrower. What information? What else? So we are afraid, or we are concerned that the interest rate will go up by 1.1. See here. So based on the past information, they found out that there's a possibility that interest rate might go up by 1.1%. Okay, so yeah, based on the information, you see, we could calculate the denominator. The denominator is the loan risk. So the loan risk could be projected using the duration method. Right? So do you remember, right, the duration method? I will write it again so you could remember it simultaneously. So we are talking about the loan, right? The asset is in the form of a loan that we will give. Right? The loan. See, still remember the logic here? So minus duration of the loan multiplied by the change in interest rate that we are concerned about, or we are afraid of, divided by 1 plus the original interest rate. Right? Okay, and of course you can move it here as usual. Okay, so what is the information again? Duration of the loan is 2.7 multiplied by the value of the loan, 1 million here. 1 million. And the change in interest rate, we saw it again. What is it again? 1.1%. And the original interest rate is, I think, here, 5. We don't see it in the information, but yeah, based on the calculation that they made, we could guess that, so this would be multiplied by 1.1% divided by 1 plus 5%. Okay, so we'll get, yeah, we get this. So 28,286. So this is the change in loan value, right? So we we use this representation, right? We use the change in the loan value as a representation of the loan risk, right? That's why, again, the loan risk can be represented using the duration method. So the change in loan value is considered the loan risk, right? So we already found the denominator, right, using the duration method. So we find the change in loan value because of the change in interest rate. So what about the numerator now? The numerator, see the information here. What will we get? Net income. Okay, so we get spread here. Spread is 0.2%. So the meaning of spread, you could see the word spread, right? It's the difference between one thing and another. So if you make money using this method, you lend out the money. Remember from our earlier discussion, like several sessions ago, you get money from your depositors, right? You get money from your depositors, and then using the money that you lend out, you make money. So you pay the interest rate here to your depositors, but you make money here. You charge interest rate on your clients or borrowers. So there's a difference here. So we call it spread. Right? So 0.2%, it means that the an example would be if you get like money from depositors and you are paying on average maybe 1.5. When you make money by lending out this money, you'll charge about 1.7. Right? You could imagine. So that's the spread, right? And it's quite low for this example. In real life, it would be higher, maybe 2%, right? 2.5% or something like that. And this financial institution also charges some fees here, 0.1% of the loan that they made, right? So in total, 0.3% of 1 million, or 3,000, right? So you see the model again here, risk-adjusted return on capital. So the numerator is this one, the proceeds that we will get, 0.3% in total of 1 million, so 3,000. And then the denominator is again the risk, loan risk. So this loan risk was estimated using the duration method, right, to find the change in the loan value because of the change in interest rate. So we get 10.61. And then your financial institution, or you will make a decision as to whether this is good enough, right? 10.61, do you think it's good enough? I mean, could it cover your cost of fund, right? The cost of borrowing that you yourself have, for example, from depositors, from issuing a bond or anything. If it's better than the cost of fund that you'll go ahead to lend out the money to this company or this person. Otherwise, you will not do it, right? Any question for this one? It's quite straightforward. The risk-adjusted return on capital, right? You saw it over and over again, the duration method, right? That in this case, we are using the duration method to estimate the denominator, the loan risk, right? Loan risk. Any questions so far? Right, so they're not difficult, okay? And even if you forget, you can always go back to the text or YouTube and other sources. I think you just need more, exercise in real life, right? Later, when you work on it, if you do it every day, then of course you'll be accustomed to estimating everything using those methods. It depends on what we are using. Any questions so far? And yeah, okay, we'll continue with the next model. This is, I think, the last model for the quantitative model of credit risk. So option model. So this has a long story. Option model. So option pricing model was firstly, published by Black and Scholes, Black and Scholes in 1973. So they called it the OPM, option pricing model. So this inspires a lot of derivations of the option pricing model. So now we have been using the option pricing model for valuing many things, but the original use was to value the option value, the option securities, right? The derivative securities called option. And it's very interesting that the Black and Scholes and then some scholars or experts afterward, like Robert Merton, right? So they even, I think, once they became billionaires by using their own method. So it's quite good, right? So usually, if you are an academic, you conduct research and you publish papers or you find some pattern of findings or something like that. Usually, it's just for your office work, to fulfill your obligations and to get to a higher rank, maybe to a full professorship and something like that. But what happened to Black, Scholes, Robert Merton, and others? They became billionaires, right, because of their own formula. So that's quite good, right? So and also they they got Nobel Prizes later in later years. So they got Nobel Prize and they became billionaires. So it's quite good news for this one. But there was quite a long story about the option pricing model. So after the Second World War, there's an economist from America, Paul Samuelson. So he was traveling to Europe, right? And if a professor travels everywhere, I think one of the top destinations of the professor would be another campus, right? Another school. So this Samuelson went to Sorbonne, right? The Université de Paris, le premier, right? Sorbonne, Paris the first, right? And so he went to like dissertation library, right? And suddenly he found a dissertation draft that surprisingly never came out at that time, maybe because of the war, right? Because of the Second World War. So there's I think, dissertation by a young guy named Bachelier, right? But I think he never took off. Maybe he died earlier or something like that. But to make the story short, I think Paul Samuelson got a lot of inspiration from this dissertation that he brought back to the United States. And then all other scholars afterward, like Black and Scholes, Bob Merton and other people, they got a lot of benefits from Paul Samuelson. You see, right? So they were so fortunate. They used their own method, and some years later they got Nobel prizes, but they also became billionaires by opening their own hedge fund companies. Okay, so this is one of the uses of the option model. Right? So we use the option pricing method to evaluate the loan value, right? Loan value that you use. So just imagine if you're a financial institution, you're a bank. If you're an owner of the bank, you see here. So sorry, I should rephrase my statement. If you're an owner of a company, right? You could imagine you're a company here. You borrow money, right? You borrow money to expand your business. So if your assets are doing well, right? If your assets are doing well, so you are happy, right? You are happy. So you will repay your debt. Agree, right? You get a lot of money, your assets increase in value, so you will repay your debt. But the additional benefits, the increasing benefits are enjoyed by yourself. Good news, right? So you see, you borrow money. If with the money that you borrow, with the loan that you borrow, you could improve your assets, then the additional value of the assets belongs to you, right? Because you only repay your debt based on your obligation or your promise to the financial institution. But what happens if the loan doesn't work out, right? So you fail, right? You borrow money, you try to expand your business, but you fail. What is the maximum loss that you will suffer as an owner of the company? Only this one, right? Only no, the money that you invest or you invested in the company. You see, this is like an option, right, to the owner of the company. I could imagine again that Tim, if you invest, right, you borrow money from, let's say you borrow money from Dina, right? So with the money, if you are successful, the additional success or the additional value creation that you enjoy will belong to you only, because you will repay Dina based on your obligation, right? The principal and the interest payment. But if you fail, can you imagine if you fail, your business fails, your assets decrease in value, then you say goodbye, right? You say goodbye to Dina, right? Yeah, please seize my assets, right? Please confiscate my assets. So your maximum loss is only the amount of money that you have invested in the company. So we call it an option. Right? What on the other hand, what is happening to the bank, to the financial institution? So the financial institution is facing an opposite situation. If something is going well, you see here, the asset value of your client is increasing, then what will you get? Only the promised amount, right? You lend out money to this company, and this company is doing well. What will you get? Only the repayment from the company, right? Nothing more, right? But if the company's assets is going down, the company will say goodbye, right? The company will just abandon, and we might get nothing, right? We might get nothing. So this is quite, yeah, again, if you're a financial institution, yeah, this is a high risk business, right? Again, if your client is successful, you get your money back, of course, but you get like the precise amount that has been promised, right? You get nothing more than that. But if your client is not successful, doing badly, and the company just abandons everything and just says goodbye to you, then you might get nothing, right? Because the asset value is decreasing badly. Okay, so how to value this one using the option method that we just saw. So here we have the formula here. So this is the lon, right? Lon value. What is the lon value here? You could write it this way. I write it on the blank sheet so you can memorize a bit. So this is a lon value, right? Lon value. This is a function of how much borrowing, right, you're giving, right? How much borrowing you are giving, divided by, the exponent value, 2 point, do you remember from your high school mathematics? 2.7 something, right? 2.78 or something. So to the power of I is the risk-free interest rate, risk-free rate, right? The risk-free rate times T. T is the time to maturity in year, right? How many years to maturity? And then, of course, you can write it this way as well. I mean, if you want to write it this way, it's okay. Borrowing value times exponent to the power of. That's the same thing, okay? You could move it here. Okay? So I like this one better, easier to see, and then multiplied by 1 divided by D. So D is the debt ratio. Right? Debt ratio, the proportion of debt to total assets, right? How much debt you are using in proportion to your total assets, multiplied by the standardized normal distribution value of H1, right? Plus the standardized normal distribution value of H2. Okay, so it's quite easy. So we have to now we have to determine the H1 and H2, right? So H1 is a function of minus, so half of the variance. Variance is the risk of volatility, right? The volatility of the loan that we are giving times T. Okay, and then minus log value, the natural log. It's a natural logarithm of the debt ratio, right? Divided by the standard deviation. Standard deviation is the variance, the square root of the variance, right? So the square root of variance. Again, this shows the risk or volatility of the borrower, right? Multiplied by the square root of time. And then H2, which is just the same thing, similar, half the variance times T, but now this is plus, right? Plus the natural logarithm of the debt ratio, divided by the standard deviation multiplied by the square root of time. Okay, so let's see an example here. So the amount of borrowing is 100,000. Time to maturity is 1 year, so it makes it easier. 1 year. Risk-free rate is 5%. And then we know from the information or the data that the debt ratio is 90%. So this is the ratio of debt to total assets. So the debt is 90% of the assets. Right? And then here, the volatility of the loan, volatility of the borrowing or the borrower is 12%. Okay, so again, this is the standard deviation, right? Standard deviation. So this measures the volatility or the risk of the borrowing or the loan. So we put into our analysis here. So first we have to calculate the H1. So tell me what is our data again. So minus half of, what is the standard deviation? 12. What is the time again? Time? Yeah, 1 year, right? 1 year. 1 year. Plus natural logarithm of the debt ratio, 90%, right? Divided by the standard deviation. Oh, sorry, I'll have to be careful here. This is the variance. Right? And the denominator here is the standard deviation, right? Times the square root of 1. It's minus, right, for H1. Okay, so we'll do it in Excel. So we'll start from the first the numerator. So what's that? Half times what's it again? 5% squared times what's that? 1? Yeah. Okay. Minus the log of 90%. We don't need this. Yeah, it's okay. Okay, and then the denominator is what? 12% times the square root of 1 is 1, right? But if you want to write it, it's okay. 1 to the power of half. So it's the square root of 1 is of course 1. So what is H1? So minus 0.938, right? This is H1. So what about H2? Tell me again how to do H2. 0.5 times 12% squared, the variance times 1. Okay. But now plus the natural logarithm of debt ratio. The debt ratio is 90%, right? Okay, so we get the numerator, and then I think the denominator is the same. Right, it should be the same, right? The standard
Yes,
deviation,
it's
yeah, it's the same. So the standard deviation multiplied by the square root of time. So we divide numerator by denominator. So we get the H1 and H2. Right, H1 and H2. So now we can calculate this one. So now the borrowing, maybe I will move this. So we don't need the H1 anymore. So what is the amount of borrowing? 100,000. 100,000 divided by, so the E to the power of what's that? 5%. 5% times 1. Right. So 1 over D. The D is 90%, right? The left, what's that? The debt ratio. Now we have to find the standardized normal distribution value of this minus 0.938, and then the H2 is 0.8180. Right? So the normal distribution, standardized normal distribution value of H1 and H2. Okay, so we'll do it here. So the borrowing is 100,000, right? And then if you want to know what is the E again, is 2.7183, right? So what's the bottom one again? The exponent of I minus T. I minus T. So the risk-free rate is 5% times T, right? I minus T, right? Okay, so we get, this one. And then we multiply it by 1 divided by 90%. So now we have to look for the this one, H1 and H2. So we got H1 and H2. So we have to find the normal distribution value. So we use norm as this. This is very easy. Norm as this of H1. Okay, so this is the and H1. What about this one? So norm as this of H2, standardized normal distribution value of H2. Yeah, so we get this. So go back to our here. So after this one, we multiply by 1 divided by debt ratio times the normal distribution value of H1 plus normal distribution value of H2. Okay, so the amount of borrowing divided by the E, the exponent, to the power of I times T. Right? Then we multiply by, what is it again? 1 divided by 90%. then multiplied by this one, normal distribution value of H1 plus normal distribution value of H2. Yeah, so we get 93,866. Let's see, what do they get? Yeah, same, right? Yeah. This is the value of the loan based on the option pricing model. Right, option pricing model. Any questions so far? Because there's one more about the interest rate, but in the option pricing model is, yeah, just follow the formula, okay? And we have Excel, so you don't need any statistical table, right, to find the NH1, NH2, right? Just use the Excel, norm as dist, right? Normal, standard normal distribution, right? Norm as dist. Yeah, one more thing. What about if we want to know the yield spread, right? The yield, right? So this is the yield on the loan, right? The market interest rate on the loan, right? Minus the risk-free. So we could estimate this as, yeah, this one. So let me write it down. So we can calculate on the blank sheet. So this is the let's say this is the interest rate or the market rate on the loan, right? Minus the interest, minus the risk-free rate. This could be estimated as -1 divided by time. It's very easy in our example. The time is 1, right? Multiplied by the natural logarithm of yeah, the same thing again. 1 divided by debt ratio times the NH1, right? The standard normal distribution value of H1 plus yeah, no, standard normal distribution value of H2. So we put into our numbers here, equal -1 divided by, so the time to maturity in our example is 1. So good news, right? Very easy to calculate. Multiplied by, again, the natural logarithm of 1 divided by the debt ratio. In our example, the debt ratio is 90, right? And times the, yeah, I don't remember, but we'll go back to the Excel. Okay, so let's do it in Excel. So this is -1 divided by time. The time is 1, right? Good news. Multiplied by the natural logarithm of first one is what? 1 divided by 90% multiplied by this. Yeah, NH1, this one, right? NH1. Okay, plus standard normal distribution value of H2, this one. Okay. Yeah, so you get so 1.33%. Right? 1.33% is the spread, right? Right? The spread between the interest rate or the market rate that we enjoy on this loan and the risk-free rate. So you could imagine if the I, in our example, I is 5, right? 5. So if K minus I is 1.33, so what is the yield? What is this then? K minus I is 1.33. And we know that the risk-free rate is 5%. So what is K? Max, what do you think? What is K, Max?
I think 6.33%.
Yeah, 6.33%. Yes, because the I is 5%, right? The risk-free rate is 5%, and then we just calculated here. The spread is 1.33%. So obviously, the K is 6.33%. Right? So K is the market rate that you enjoy on this loan, right? So based on the option pricing model, we could estimate the yield spread that we are enjoying right now, and in this case, it's 1.33%. Right? Okay, so we have seen a lot. Yeah, so a lot of models, and they'll keep improving from time to time. You know, we have more models. It's unending learning. Right? When you go to the market, going to the job market, you have like new models maybe every day. But I think the key to using all the models is the real life experience. Right? When you do it, of course, when you do it, then you have an expertise. You'll be a resident expert on a certain thing. Right? So don't worry about it. So use your Excel, all right? Don't use your statistical tables. Any question for today's session? Yeah, so we finished the credit risk individual part. Chapter 11 will be quite short, so I think we'll see on Tuesday, okay? And I'll inform you also on Moodle about what to read for next week, and assignments for Patrick and the other Patrick. Okay, so enjoy your weekend. Take care always.